Hi everyone, my name is Stephan Wiefling and I'm from the Data and Application Security Group of HBRS University of Applied Sciences. And look what I got here. Let's see. Yeah, here. It's a bag that we got here last year at Internet Dagana, and it was a very great time because I love it being at PasswordsCon, having these great conversations. Unfortunately, this time it's online, but I'm just trying to reproduce the PasswordsCon feeling as good as possible. So yeah, thanks for having me again here. And the talk that I'm just going to give you here today is about risk-based authentication. And last year there were some questions like, how's the usability actually of risk-based authentication? And now I can finally provide answers on that because we did multiple studies and yeah, some of them will be published very soon and some of them already did. So yeah, I hope you enjoy it. And we're just talking about passwords. I mean, passwords are just deployed everywhere and we can't get away with them, hopefully, because then I just can give some talks at PasswordsCon, and if they go away, that would be very bad for us. And yeah, just to be honest, I mean, we already know why, and yeah. But however, the risk in password-based authentication just increased all over the years with password database leaks because we have like password databases from popular online services, they got stolen, and now you as an attacker can just get them from the internet and yeah, just automatically enter these username and password combinations on the website over and over again, like trying user 1, user 2, user 3. And, you know, we're just humans and we're just reusing passwords. I'm sometimes reusing passwords. So hackers will be successful at one part. And this is why credential stuffing attacks, so this is called credential stuffing, that these attacks are just at a high degree, as you can see here. So they're very popular. So we need to implement somehow additional measures just to protect our users from these attacks. And if you at least in Germany ask people about how to protect users from these attacks, they always say like, yeah, use two-factor authentication. Yeah, that seems like a sensible idea, but the problem is here that the user acceptance seems to be very low regarding that. Google themselves really had to say that less than 10% of their active Google users have just opted in for two-factor authentication, which is a very low number. If you just remember, Google just started promoting 2FA since 2011, so that's a very long time span, and it's just 10%, that's a very low number. So you really need to protect these 90% that don't have 2FA enabled. And in this case, you can use risk-based authentication. And that's what online services like Google are doing actually. So it works as follows. So you're just a user typing in your username and password at a website. And when you submit the login form, you're also submitting additional metadata that is available in the context. This could be, for example, what kind of IP address am I using? What kind of device am I using? And so on. And all this information is just compared with your previous login history and in the backend, and RBA then just calculates the risk, how highly it is that this login attempt is a hacking attempt, and this is just normally categorized into low, medium, and high risk. If you just take in the low risk example, I'm just signing in from a university as I normally do. And since this is the normal login behavior, I'm just getting signed in as always. But now I'm just switching to another location. Just take Stockholm, for example. Okay, that looks a bit weird. Let me correct it a little bit. Now it's correct. So yeah, we just went to Stockholm in this case, and I'm using a device that I've never used before. And yeah, since this is not my normal user behavior, RBA is not quite sure and it says, okay, is it really Stephan Wiefling trying to sign in here? So they're just asking for an additional authentication factor that I can give to them to prove that this is really me. In most cases, this is like an email with a 6-digit code that I just enter on the website. And if that proof is correct, then I'm just getting signed in. And yeah, online services are using it. If you haven't seen it before, you can check out my PasswordsCon talk from last year. We did some studies just to figure out who's using it, and we found out that Google is using it, Facebook, LinkedIn, and Amazon is using it, among others. And also NIST is recommending it in the NIST Digital Identity Guidelines. If you haven't read these guidelines before, just do it. There are a lot of usable security principles implemented there. So that's a really interesting read for you, I guess. However, we still have a problem that we haven't investigated at the time when we concepted the studies, because RBA, it might be used on websites, but we don't know how the usability is. And this could be a problem because we have like unpredictable system behavior, because sometimes you're asked for additional authentication and sometimes you're not. And this is why we constructed and designed a study just to investigate the usability and security perceptions of risk-based authentication. You will get, actually, this will be published at the EXEC conference in December, so you get a preview of that. So yeah, we constructed a study just to investigate how the security and usability perceptions are. And yeah, just to do that, we designed a cloud storage website where you can do stuff that you can do on a cloud storage website, like uploading and downloading data. You can take a picture of yourself, which is sensitive data actually in Germany. So this is interesting to know, or important to know here. So data sensitivity could be high on this website. And we tested the website by introducing the website to our participants as an external website. So yeah, this is a cloud storage website. We would like to know how you think about that. It is not linked, this study website was not linked to our university, just to avoid bias. And yeah, they registered with their personal devices on the website. So they used their private email address and the device, their private devices. So to create a realistic study scenario here. And when they signed into the website, they perceived one of 4 authentication methods. So per each participant, it was one of 4 authentication methods they perceived. So we selected them and everyone perceived one of them. And yeah, if we had a condition where all participants, where the participants in the condition were asked always for additional authentication. So this is just like the classical two-factor authentication. And we also tested 2 different variations of RBA. One was always triggered when the device was different, and the other one was always triggered when the location was new and different. So this is what we also found in the wild. So just to reproduce it here, and also to have some comparison to, the classical password-only authentication, we had a condition where we never asked for additional authentication, just to compare it. We had a challenge in our study design also, because authentication is always as a secondary task. You have one task, for example, like logging into a cloud storage website. And then while you're doing that, the authentication method gets into the way. So just to investigate that, we needed to design tasks, realistic tasks, which, are not the authentication method. So we never said that we were testing authentication methods to avoid bias. And we designed 7 tasks. They solved these 7 tasks using their private device. So they one private device, and they switched the location and used 2 different devices they have never used before in that case. And the task also introduced some sensitive data just to increase the immersion into the scenario. And to also support more the immersion into the study scenario, we introduced room changes in our study. Room 1 where they used their private devices, was just a normal study room, which they knew from the university. So just like a normal boring office room. And then we just asked them after some tasks to switch the rooms. And when they entered the new room, they were a little bit like shocked, because they never knew a room that looked as beautiful as this one at the university. Just trust us. So this method also helped participants to increase the immersion into the study scenario here. And in this case, as you see, the location-based RBA was triggered. So we also introduced these tasks just to perceive the differences between the authentication methods. So after they finished the task, we wanted to figure out how are their actual usability and security perceptions. So we designed an exit survey, which they answered. They included some usability and security perceptions here that we measured. So we wanted to measure that, of course, how people perceive it. And after that, we wanted to figure out why did the participants cross certain answers. So we also did a semi-structured interview here. So we asked them some questions. Why did you choose certain answers? And also wanted to figure out their personal experiences with websites. So perhaps they perceived RWA. So we wanted to gather that information here. And these are our results. We had a young population, 65 participants. It's more skewed to male population, but we also had female persons and one person that did not state the gender in our study. So it's also, a young population here. And the results that we had here, we also measured the usability using the system usability scale. These are 10 standardized questions, and depending on how they answer the question, we calculate a score between 0 and 100, and the higher the score, the higher the usability. And you can clearly see here on the graph that the usability of 2FA was significantly lower than password-only and risk-based authentication. Regarding the user acceptance, we could see that the user acceptance of RWA was significantly higher than those of 2FA. So, but the difference here that we saw is that the acceptance differs on the use case scenario that we actually have here, because it really depends on what's the re-authentication factor you're offering, and also what is the data sensitivity in that use case scenario. So what kind of data is stored on the website and how sensitive do participants consider it? Because that's what we also asked in our survey. So we asked them if they were willing to use this authentication method on certain websites, and also if they were willing to use it if they had to give their personal email address for this purpose. And in this case, the acceptance was overall pretty high. But when we asked for a phone number, this acceptance really declined. And you can see here on the graphs that for online banking, the acceptance is really high also here. Maybe this is just a German kind of thing, but also the willingness to use an app was also quite similar. And also in terms of online banking, people were really willing to use 2FA also in that case. So they were also willing to accept being annoyed a little bit, but have more security. But there are differences here, as you can see on websites with lower sensitivity, people preferred other authentication methods here and other authentication factors. There are also more factors as we get some insights here in our interview questions. So what are also factors influencing the acceptance of 2FA or RBA? One of them is the trust in the online service. One participant was not willing to give the phone number again to a social media website because the person just offered it, the phone number, and was then not only asked for additional authentication via this text message they received, and they also advertised and spammed them a lot. So this is so the trust in the online services seems to be very important here, and also the device involved. There was one person that used Netflix, and when signing in, Netflix triggered sometimes for RBA, and do you have an email account installed on your television screen? I guess not. That's a pretty dumb idea, I think. And this is also why this person was quite annoyed when Netflix asked for additional authentication. So you really need to care about what's also the device involved here. Regarding the security, we can see a clear tendency when you asked for additional authentication at least once, people feel more protected. And this is a good sign also for RBA, which you can see here. So the acceptance, this perceived security was significantly higher for 2FA and RBA in that cases here. We also had some additional findings in our study, some problems that happened actually when we did the study here. So we asked for additional authentication via email in the 2FA and RBA conditions when they were triggered. And some of our participants, because we asked them to use their private email address, some of them use Gmail. So they signed into their Google accounts. And when they had a different device or location, Google also had RBA enabled. Yeah, sure. Because we had Google is using RBA, as we know before. And the problem is here, if you don't have your device with you to confirm it, you're getting locked out of your account. So this is not a good option here. And the problem is here that 1/5 of our participants really had this problem and didn't have their device in this special room. So really need to tackle that. And they also had negative experience where it really happened in the past, especially when the battery is flat and you couldn't have another device to confirm it. This was a problem here. And also with shared accounts, this seems to be a problem. So really need to tackle that if you're an RBA developer or deployer. So really need to care about what is the second factor you're actually offering here for re-authentication. So after we figure out what's the usability of RBA, we did another additional study just to figure out more about re-authentication methods. Because if you watch the PasswordsCon talk from last year, you know that using the email as a verification factor seems to be the state of the art regarding risk-based authentication, and also using a 6-digit code in the email. However, we thought if you're using different devices for verifying, like you sign in on a desktop device and have a mobile phone with you, it could take more time when verifying. So we're just wondering why online servers are not using other methods than these 6-digit codes in the email body. So we investigated that by constructing a study just to investigate how actually if there's a potential to improve this method here. So yeah, it's a similar study procedure as the last time. They registered on the website, and after that, we just asked when they signed in on the website for additional authentication, and the login method differed between each condition. So we had 3 conditions here, and condition 1 was they had to re-authenticate with the state-of-the-art deployments that we know from practice. So email in the code is in the body and not in the email header. And since we already saw it on email registering purposes on some websites, we were just wondering, why don't you just put the code inside the email header? And this is what we did in the second condition. So this is not the case in RBA right now. So yeah, we put the code in the email header. So this was condition 2. And since we also knew it from last year, there were some talks about magic links. So, and since people are always propagating magic links as the future in authentication, we were also thinking about, yeah, you could also construct something like magic links, perhaps for risk-based authentication, but we really adapted it for our special scenario in order to prevent prefetching links that could, so you had a link that you just click here, and just to verify that it's, if you're using a different device, just to make sure, we had an extra confirmation here when you're using the mobile phone to confirm it, which could be the case here. You're also asked just to click on yes here, just to confirm it, similar to a Google dialog here, and then you just confirmed and getting signed in on your main device. And what's a fun fact about that? 1 year after we did the study and after our paper was already accepted, we just found it that Amazon really deployed this method. So just in the way as we design it, so you have to click the link, confirm it, and then you're signed into Amazon. So you basically now can find some results on stuff that is also widely or deployed at least at one online service, just to figure out how people perceive it. Just to compare these methods, we measured the times, how long it takes to finish the study. So the time 1 that we measured was how long does the re-authentication time take in total. And the second time that we measured was how long does the finishing the login challenge itself take, just to confirm in terms of usability, how they really perform. And these are our results. And you can see here, we had a young population. So not a young population, we had a diverse population here where we did the study via Amazon Mechanical Turk, which is an online platform just to pay participants to finish a study. And since this was a reactional study, it worked quite good for our study purpose. We had a diverse population between gender and also the age, which is quite good. And we had some differences here actually in how the authentication methods perform. It performed faster in 2 cases. One case was when we had code-based re-authentication. when using the desktop PC for signing in and re-authentication, so it's on the same device, the code-based challenges were so faster. And based on our analysis, it took faster because, they just copied and pasted the code actually here. And on link-based re-authentication methods, it performed faster when the devices were different. So if you're just taking your mobile phone out and just completing the challenge here, it was faster when you were just using the mobile phone. So there were some performance improvements. However, if you take it in total, it wasn't that fast, the link-based method. So we were a little bit disappointed here, but the code-based method, so if you're having the code in the email header, it really had an effect, and a significantly faster challenge. The re-authentication time was significantly faster in that respect. We also wanted to measure the sentiment because it's also a factor accepting it if users are accepting it. So we did similar to Max, who did it on another purpose. We just asked the participants to state 3 feelings they had when they verified their identity. And it was a free answer. And after that, we filtered these answers and ranked how often they were mentioned. And across all the 3 conditions, it was just quite, we have positive feelings, negative feelings, but also overall, they are quite similar here. But we really had some differences between the conditions, which were quite interesting. One of them was, if you're just using a link-based method, the people were significantly more scared, more anxious here in that case. And why is that? Based on the replies we got, we think that this could be due to phishing awareness campaigns. So they know not to click on links, and now we're just asking them to do the opposite. So this is why people are not tend to accept it right here. And also, if you're just using the code-based methods, if you're using the code in the email body and subject line, it really had a positive effect because people were significantly less nervous, maybe because they didn't need to answer, to open the email, just to open the email because they knew what to expect here. So this could be also why it had a positive effect here. So just to conclude, regarding the overall reusability perceptions, we saw that RWA performed better in terms of usability than comparable to factor authentication methods. Also, the security of risk-based authentication is significantly higher than password-only authentication, but you really need to be careful about how you implement risk-based authentication. Regarding the re-authentication methods, we saw that using the email code in the header and the body had a positive effect. So this was a clear winner because also the participants were significantly less nervous in that respect. We were a little bit disappointed regarding the link-based re-authentication method. We had better expectations here, but however, the overall effects that we had here showed that it wasn't a good idea to implement it right now. But regarding the winner that we had here, it is not the current state of the art. So we would like to appeal to website owners just to revise probably their current RWA implementations. So at the end, we can say that you should consider RWA on websites with sensitive data involved. Only exception is online banking, because in this case, users were tending to accept 2FA more to feel more secure. Because they are, even though they were annoyed in that respect a little bit. As we saw, email-based re-authentication, it's probably not the best method here, but depending on your service, it seems to be mostly accepted. But you really have to care about what kind of, how do you actually implement the method? And you really need to be aware of deadlocks. What is the additional authentication factor you're offering? Is there a fallback method somehow? Because as you saw in the Gmail example, it could be a very big problem if you don't get into your website and you're a legitimate user. So thank you very much. It was a pleasure just to be here back again at PasswordsCon 2020, this time online. If you got any more questions, just drop me a line on Twitter. Just give me some questions in the chat right now if you're live watching this one, or I'm contactable via email as well, or we have a website actually where we also collect more information on risk-based authentication. We do multiple studies and we did some. So just go onto our website, riskbasedauthentication.org, just to figure out more. And I'm very happy right now to very looking forward just to answer your questions. So thank you very much.